Hi friends, this is Santosh from Sanvihan Technologies. Okay, today we are going to discuss on Java, the demo on Java. I'm going to give the demo on Java. Okay. Yes. Yeah. See, this tutorial provides the basic and advanced concepts which are useful for beginners and working professionals. Okay. Actually, what is Java? Okay, Java is a programming language which is nothing but object-oriented programming language. Okay, we can say Java is a programming language. Okay, it is nothing but object-oriented programming language. Actually, what is object-oriented programming? And object-oriented programming is nothing but which supports OOPS features, object-oriented programming features. Okay, what are OOPS features we have in Java? Okay, we have classes and objects, encapsulation, inheritance, polymorphism, abstraction. Okay, these all are the OOPS features of Java. Means these OOPS features are not meant for only Java. Okay, we have some other programming languages called C++. Okay, C++ also supports object-oriented programming features. Okay, object-oriented programming features are universal. Okay, the main aim of object-oriented programming features is nothing but we can have security. Okay, we can have uh, like creating type of objects and a class. I will give you some overview of object-oriented programming features. For example, classes and objects. Okay, classes and objects. Okay, what is a class? A class is nothing but which is a blueprint of an object. I'll tell you one example. See, example is nothing but house plan is a class. House plan. See, when you want to buy a house, you don't see an object of the house there. Okay, but the builder will be giving you the plan of the house, but not the object itself. Okay, that house plan is nothing but a class. Okay, then what is an object? An object is nothing but a uh, the presentation of that object is nothing but an object. Okay, that is class and object. Here in a class, we have some data members and methods and methods. Okay, that is nothing but a class. Okay, see in Java, every program execution starts from a class. Means we have a method called a main method. Okay, that main method is written in class. Everything is a class in Java. Everything, what we write, everything is a class in Java. Okay, we write in the class only. We write in the class only. Okay, everything, whatever we write, everything we write in class only. For example, if you take C language, in C language you will be writing main method, main function. Okay, in main function you will be writing all the statements. Okay, but in Java it is not like that. Everything we will be writing in the class only. For example, I will give you one example of that. See, this is the example. Okay, this is a Java program, which is nothing but a class. A Java program will be starting with a class. Okay, this is class test. Okay, everything whatever you write in the Java program is written in the class only. class test open flower base and close flower base. Okay, here you will be writing statements, methods like that. Okay, these statements, methods, and everything we will be covering in the future classes. Don't worry about that. Okay, this is some basics and demo, so that only so that simply I'm giving you what is a class and what that class contains. Yes, and here uh, in those features we have encapsulation, inheritance, polymorphism, abstraction, data, heading. These all you will be learning when we come to the OOPS features. Okay, next, Java is a secure programming language. Tell me why it is secure. Why it is secure means here in Java, when you write a program, okay, when you compile the program or when you run a program, okay, it will be modified to bytecode. Okay, suppose we have in Java we will be having the extension as .java program, .java. Okay, when you compile the program, it becomes as .class file. Okay, that .class file will be written in bytecode. That bytecode cannot be understood by anyone. That bytecode cannot be understood by anyone. That is why this .class file we can take and we can execute anywhere, so that it is secure. So that it is secure. Okay. This Java is a secure programming language. Next, it is platform independent language. That is means what is platform independent language? Platform independent language is nothing but, okay, we will be writing the code in one operating system and run the code in any operating system. Okay. For example, this is Windows operating system. This is Linux operating system. Okay. See, for example, we have three operating systems. We have, okay, Windows operating system, Linux operating system, and Mac operating system. Okay. Here we have written a class called. Here we have written a class called. We have written a Java program. For example, we have written test.java in Windows operating system. Okay. When we write test.java in Windows operating system, then at that time, when we compile the program, the test.java will be converted into test.class. Test.class. Okay. This test.class we can run in any operating system. This test.java, when you compile the program of test.java, will be converted into test.class file. Okay. For running, we have to run that test.class file. Okay, that test.class file we can copy from our Windows operating system to another operating system, any other operating system, for example, Linux operating system, and we can run the test.class file in Linux operating system or Mac operating system. Okay, write once write once is nothing but we can write the program once and we can run anywhere. We can run the program anywhere. Okay, that is platform independence. Okay, next, Java is a compiled programming language, but rather than compile straight to executable machine code. See, Java is a compiled programming language. How can you say it as a compiled programming language? Okay, when Java is a compiled programming language, here what happens means when we compile the Java program, it compiles that program and it converts to the machine code. It converts to the machine code. Okay, that machine code will be compiled and run the program, and we can run the program by using that machine code. Okay, and Java uses both compiler and interpreter. Java uses both compiler and interpreter. Okay, in Java, the compiled code, the compiler of code, we call it as Java C. Java C, and in Java, whatever the code you compile, that will be converted to bytecode file. Okay, that bytecode file is nothing but dot class file. Dot class file. Okay, that dot class file is unique for all the operating systems, and that contains the bytecode format. Okay, now the interpreter. The interpreter of Java, what it does means it converts that bytecode to specific operating system compatible machine code. Okay, this code will vary according to operating system. Understood? I'll tell you this point once again. See, Java uses both compiler and interpreter. Okay, the compiler of the Java code is nothing but Java C. See, for example, I have this test.java. I have this test.java. Okay, I compiled this test.java. When I compile this test.java, okay, it when it compiles, it converts that to test.class file. Test.class file. Okay, when it converts to test.class file, then at that time, when you compile the test.java, then it converts to test.class file. Okay, test.class file. Then that is the job of compiler. Next, when you run that program, then interpreter will come into picture. Okay, then this bytecode, what it does means, this bytecode we can convert. See, here we have test.java and test.class after compiling. This test.class we need to put into Linux operating system or Mac operating system. Okay, this test.class. Okay, when you run this test.class in Linux operating system or Mac operating system, then at that time, interpreter comes into picture. What that interpreter does means, interpreter will be changing the test.class file and running the test.class file into specific operating system. Okay. Here, what is I'm telling compiler and I'm telling interpreter. Actually, what is the difference between compiler and interpreter? What is compiler? What is interpreter? Okay. See, for example, we are humans. We are humans. Humans. We can understand English language only, but computer doesn't understand English language. What computer understands? Computer understands zeros and ones. That is machine language code. That is machine language code. Okay. Means computer needs a translator to convert the languages into human readable form, to the computer readable form. Okay, means here we have a computer and Santosh from some new technologies. Okay, I can understand English. I can understand English. But my laptop or desktop doesn't understand English. Okay, my laptop or desktop understands only machine code. Only machine code. Okay, then We need a translator to convert the human readable form to machine code or machine code to human readable form. Okay, what is that language translator? That is a software, okay, which translates the programs from a source language that are human readable form to an equivalent program in an object language. Okay, the source language is nothing but high-level programming language, which we write by using C or Java or Python or any type of programming language. Okay, the object language is nothing but a machine language of an actual computer. Okay, here we have two types of translators called compiler and interpreter. Compiler and interpreter. Okay, compiler was invented by Grace Hopper, and interpreter was invented by Steve Russell. Okay, got it? What is a language translator? A language translator is software which translates the programs from human readable form to machine code. Human readable form to machine code. Okay. See, now I am going to compiler. Actually, what is compiler? See, a compiler is nothing but which reads a program written in the high-level language and converts it into the machine code or low-level language that reports the errors present in the program. Say, for example, I have written program called test.java. Okay, test.java I have written normal code like some code. I'll write that code also. For example, I'll be writing a class test. See, this is the first class, so you may not understand this code. If you know any other languages called C language, you can understand this code. But when I start the coding, the first program, I will be explaining you everything here, everything which is nothing but class and this main method. Okay, first now as this is the demo, so simply I'm giving you the overview of this class test. Okay, see, every Java program starts from class. Okay, class test public static void main string args. This is a main method which every Java program starts main main method. Okay, you forget that when I start the first application, I will be explaining you why it is public, why it is static, why it is main, why it is void, and why we are declaring as string args. Okay, now I am telling you what is a compiler and interpreter. So understand that this I will be giving you brief on these all things. Okay, so no need to worry of that. See, this is my Java program. Okay, this I saved as test.java. Okay, here we are humans, so we can understand what is A, what is B, what is C. Okay, I'm assigning a value to A, I'm assigning a value to B, and I'm adding the two values and printing the two values. Okay, now I understood this, but when you compile the program, what does that compiler do means compiler will convert this high level language to machine code. Okay, machine code. Then machine code, that is the job of the compiler. Okay. See, so that it converts the entire source code in one go to execute. Okay. Another job of compiler is, okay, compiler executes the total code and checks if any errors are present. Then it will be reporting the errors when after completing the execution of the total code. After completing the execution of the total code. For example, I forgot to write semicolon here. I forgot to write semicolon here. I forgot int b is equal to 20 like this. Okay. Now we have two errors in this program. This is one error. In this line, we have one error. We forgot to write semicolon. And in this line, we have another error. Okay. We did not give equal to. Means we have two errors in this program. Okay. Now, the job of compiler is to execute the total program, and after executing the total program, it reports the error is in this line, means 1 2 3 4 5 fifth line and sixth line. It will show these two errors after execution. Okay, means it will be executing the total program at once and shows the errors are in fifth and sixth line. It will be reporting the errors. That is the job of the compiler. Okay. The main advantage of compiler is it is not line by line execution. Line by line execution means first execute this line, and if any error is there in this line, report the error, and execute in this line, and execute this line like that. Okay. Interpreter. Interpreter is nothing but it is an alternative for implementing a programming language that does the same work as compiler. Okay. What interpreter does means, interpreter is nothing but it performs lexing, parsing, and type checking similar to a compiler. Means it performs checking, okay, parsing and type checking similar to the compiler. But interpreter, what it does means, it is the main difference between compiler and interpreter is, see, interpreter checks line by line execution. Interpreter is line by line execution. Line by line execution in the sense, first it checks in this line, is there any error? No, no error. Then it comes to this line. Is there any error? No error. Then it comes to this line. Is there any error? Then no. So comes to next line. Is there any error? No. Is there any error here? Yes. Then report that error. But what does compiler do? Compiler executes the total program at once and reports the errors afterwards. But interpreter is not like that. Interpreter is nothing but execute this line, reports the error. Okay. Okay. When you rectify that error, again execute this line. Again you have to rectify this line. Again execute this line. Again we have to rectify this. If any errors are there, again execute this line like that. Means interpreter is line by line execution. A compiler is not line by line execution. Compiler executes the total code at once and reports errors in so and so lines. But interpreter executes line by line execution. Okay. For every line it gives, if any error is there, it reports an error. Then we have to rectify each and every line. That is the job of interpreter. Okay. See, here we have, this is Java source code. Okay. Java compiler. Java source code will be compiled by using Java compiler. Then this Java compiler will be changing to bytecode, and this bytecode is loaded into JVM. JVM is nothing but Java virtual machine. Java virtual machine which loads which bytecode is loaded into the JVM. Okay, the Java virtual machine is nothing but which when you execute a Java program, Java virtual machine will be executing a Java program. When you run the Java program, okay, then Java interpreter comes into picture when you execute the Java program, then it goes to the operating system. Okay, Java uses compiler and interpreter both to execute a Java program. Okay, where Java is used, where we use Java, very important. See, Java is used in mobile applications, desktop applications, web applications, web servers and application servers, games, database, and everywhere Java is used. Okay, and why we have to use Java? Java works on different platforms, any type of platform. It is one of the most popular languages in the world. It is easy to learn and simple to use. It is secure. It is an object-oriented programming language. And it is reusable. It is reusable. For example, I'll tell you where Java is used and why Java is used. For example, you take IRCTC website. In IRCTC website, we use Java. IRCTC is nothing but it is a web application. Java is used more in web applications. Java is a web application. IRCTC is a web application which uses Java. Okay, if you want to book a ticket, okay, if you want to book a ticket, if you want to cancel a ticket, if you want to do the bookings or a cancellation or anything due to select a berth, okay, upper berth, lower berth, middle berth, anything. Okay, there also Java is used. Okay, login, registration, registration. Okay, everywhere. And IRCTC is a web application which uses Java. Okay, games and mobile applications, especially Android applications. Okay, in Android applications also we use Java. See, for example, when you buy a new phone and when you get an Android, sometimes you will be getting Java not running like that, some errors. Internally, it uses Java. Okay, and desktop applications, for example. Desktop applications, applets, swings, AWT. It is nothing but Java. Okay, and web servers and application servers. Okay, we have the servers called Tomcat, WebLogic, WebSphere application server. Okay, there also we use Java. And games, so in games also we use Java. Animations, we use Java. Why? Why we have to use Java? Why? Because it is secure. The main aim of Java is security. Okay. For example, if you take C language is not secure. Why? Why? Because in C language, we have a concept called pointers. We can store address of a variable. But in Java, there is no address. But we have references. Okay, that is nothing but security. Okay, now we have some types of applications. Okay, there are mainly 4 types of applications that can be created using Java language. That is nothing but standalone application, web application, enterprise application, and mobile application. Okay, what is standalone application? A standalone application is nothing but simple Java program, which is nothing but desktop application or Windows-based application. A simple Java program is nothing but standalone application, means which contains 4 Java standards. Java SE, Java Standard Edition. It's normal core Java. In core Java, we have so many things: collections, multi-threading, okay, OOPS concepts, exception handling, Okay, these all are very, very important. That is standalone applications, which are nothing but desktop applications, or we can say window-based applications. Okay, web application. What is a web application? A web application is nothing but which runs on server side. Okay, we have Java frameworks. We have JEE, Java Enterprise Edition. Okay, here in web applications, we will be having, okay, the technologies called servlets, JSP, servlet, JSP, structs, Spring, etc. The technologies which are used in web applications in Java, for creating web applications in Java. Okay, means it creates a dynamic pages. It creates dynamic pages, which is not nothing but web applications. For example, you take IRCTC website only. Okay, in IRCTC website, first you will be having a login screen. Login screen. Okay, you will be writing username, you will be entering username and password and clicking on submit button. When you click on submit button, then it goes to the specific page. Okay, that is nothing but a web application which run on any server, whether Tomcat, WebLogic, web application server like that. Okay, that is a web application. Okay, that is done by using JSPs. Okay, like IRCTC, we have Gmail. We have Gmail. In Gmail, when you log in and you enter username, password, you click on submit button, then it goes to your inbox. And when you click on the mail what you have got, then it goes to the specific email. Okay, that is nothing but a web application. Next, enterprise application. An application that is distributed in nature, that is such as banking applications. Banking applications are called enterprise applications. Why? Because banking applications are very huge. Means we need to maintain deposit, we need to maintain withdrawal, we need to maintain all the transactions of the members. Suppose if a person has taken an account in that bank, if if that person if that person's account is for 15 years, 20 years, 30 years, 40 years, we need to maintain the data of that person securely. We need to maintain the data of that person securely. What are the deposits? What are the what he deposits? What he withdraws? And what he does the banking transaction? What are the payments he is making? What to which account he is transferring? We need to maintain all the things, and contains load balancing. In Java, we use EJB for creating all the enterprise applications. But now EJB is outdated. Okay. Instead of EJB, they are using Spring JEE module. Okay. In Spring JEE module, this enterprise application comes into picture. Okay. Next, mobile application. Okay, an application which is created for mobile devices is called a mobile application. Currently, this Android and Java ME are used for creating mobile applications. Okay, in Android we will be having so many features, and we have a technology called Java ME, Java Mobile Enterprise. Okay, this Java is used in mobile applications also. Okay, this is about types of Java applications. And we have Java platforms. As I discussed in the previous slide, Java SE, Java EE, and Java ME. Java SE contains APIs like Java.lang, strings, exceptions, multi-threading, IOs, reflection, collection framework, everything. Okay, Java EE is nothing but it is an enterprise application which contains all EJB, JPA, and web services. Okay, servlet, JSP, everything. This is Java EE. Means it is nothing but it uses the technologies like servlet, JSP, web services, Spring, Hibernate. Okay, that is nothing but Java EE. Java ME is nothing but Java micro edition. Okay, which is mainly used for mobile applications. Which is mainly used for mobile applications. Okay, understood all of you? Okay. As this is my demo class today, okay, in the next class, I'll be discussing all the topics which we cover in core Java, and from next class onwards, like I'll be going into depth. Okay, in core Java, if you know core Java, if you know core Java, everything, every language or every framework is based upon core Java only. You take J2E technology is called JDBC, sublets, JSPs. Okay, that is based upon core Java only. If you take frameworks like Spring, Hibernate, web services, that is also based upon core Java only. Okay, so learn core Java, then you can understand every framework or technology. Every framework or technology. Okay, any questions? Okay, then we can continue in the next class. Okay, this I'll be putting this video on YouTube, so you can watch this. Okay, and like, share, and subscribe our channel. My name is Santosh. I am from Sun Beyond Technologies. Okay, thank you.